In this video series, we have been studying the mixed design, specifically a one between subjects factor and one within subjects factor design. And it is the fact that one of the factors are between subjects and one within subjects that make us refer to this as a mixed design. And it's now time for me to accept my research challenge. I've been asked to analyze the Rogaine data to determine if Rogaine can promote hair growth in women with androgenetic alopecia. So that is what we're going to do here. We've actually done that throughout the video series, but I have to put it all together in a report format. So that's what I'm going to do now. So here I have put the question up at the top, or the research challenge up here at the top. I'm going to go ahead and take it out of there now and just start working through and showing you all the aspects of my design and how I wrote things up. So the first thing I'm doing is loading in the data, and remember two things. One is that we're going to have both a wide format, which I load in here, as well as a long format, which I load in here, because different aspects of the analysis are going to be easier to do with wide format than long, and vice versa. And then the second thing to remember is that anytime I'm dealing with a categorical variable, I need to label it as a factor. And so I do that right at the beginning as well. Okay, so let me go ahead and knit what I have here, and let's go ahead and take a look at how I've described this. Androgenetic alopecia, also known as pattern baldness, is a common condition, but one that can be especially disconcerting for women. Price and Menifee conducted an experiment to assess the effect of minoxidil, with the brand name Rogaine, on daily weight gain of hair in women with this condition. The women in the study were randomly assigned to placebo and treatment conditions. Daily hair weight gain was measured prior to the intervention, as well as every 8 weeks for a total of 32 weeks after implementation. In this report, I will analyze the data to determine the effectiveness of Rogaine as a treatment for androgenetic alopecia. And I have here the reference that anyone can look up the article if they wish to. So the first thing I do in the analysis is something I frequently do first in the analysis, and that is I show box plots. The reason I like these is because it shows the major features of a distribution by showing the 5-number summary within a form and the range and interquartile range as part of that 5-number summary. So here I'm showing the box plots in figure 1, and I notice that I have a little caption here, figure 1. To illustrate the average daily weight of hair for each measurement period, note that the greater variation in the treatment condition was even before the treatment. But I'm also probably should have mentioned, I don't know, I guess I should have mentioned this, but I'm not going to worry about putting it in because I'll mention it to you verbally. Remember that we're dealing with only 4 women in each of these possible conditions. So 4 in Rogaine, 4 in treatment. Note that the same 4 women in the treatment appear in all the treatment box plots, the green ones, and similarly, the same 4 women in the control appear in the yellow box plots. And then I drill down with some descriptive statistics. Table 1 consists of descriptive statistics for each condition at each time of measurement. The means demonstrate that the treatment caused hair weight gain for the sample. The change from pre-treatment to the end of the study for the control group was an average of 0.004 milligrams per centimeter squared, while for this same period, it was an average of 0.062 milligrams per centimeter squared. And I didn't say here for the treatment, so I better put that in. Let's see. Well, for this same here is an average of 0.062 milligrams for the treatment, for the treatment group. Okay, so we've added that. Now, while I'm here, I'm also going to show you something that I have not shown you in past reports. I've added this little argument here to the top of my code chunk, and that is comment equals NA. You see I have echo equals false, which you're used to. That keeps the code from showing in the final output. But what does comma equal NA do? Well, let me go ahead and knit this revised version and let's take a look. If you remember in the past when we did the descriptive statistics like this in base R, there were hashtags at the beginning. That comment equals NA in the code chunk keeps the hashtags out, so it just basically cleans up these descriptive statistics a little bit. Figure 2 illustrates the mean daily weight of hair samples across the 32 weeks. The women receiving Rogaine had greater hair weight gain. There is a leveling off of weight gains after week 16, though the increased hair weight is maintained after that and throughout the duration of the study. And this mean graph, this line graph of means, clearly shows the patterns and shows the interaction. And that is the key element of a mixed design. We want to look at the interaction to see if the rate of growth in this example for the treatment condition is different than it is for the control condition. And at least that is the case here in the sample. We know it's the case. So we might want to go now to inference. And so I mentioned here that before I consider whether these experimental results can be inferred to the larger population of women experiencing alopecia, I need to check the conditions for inference. Figure 3 is a normal QQ plot. This plot suggests the residuals are larger than we would expect beyond the first standard deviation on the right side of the distribution. There are 40 observations, so that inferential probabilities will not be as concerning as the plot indicates. Yet I'm going to still caution the reader these probabilities are not exact because 40 is still not that large, and we have some pretty large discrepancies up here on the positive side and some discrepancies on the negative side from what we would expect. So I want to show you also that when I made that plot, as I was making that plot, I ended up doing it a little bit different than I did when in a previous video I created the plot. And the reason why is because I was having a hard time controlling the text on the axis and also eliminating the title with the way I did it before. You might recall that before I actually used a projection. The way I handled it this time was to use a model that might be a little bit misleading here because what I'm doing is I'm putting in the weight, of course, is a response. That's the same as always. I'm taking the treatment condition and I'm taking that treatment condition here, that's what's called the hair here, and I'm looking at it crossed with time. But then notice that I'm adding in here a hair long ID as though it was something other than error, as though it was actually something I was interested in looking at. And so that's not quite right, but it gives me the right residuals. So the way I did it before, I did it that way, so using projections, so I could actually put in the correct model and then get the residuals. This is putting in a model that's not quite correct, but still gives me the exact same residuals and allows me to use then the QQ norm as I have in past videos and the QQ line and control things like here you see I say main equals and an empty string in order to get rid of the title here. And that's what was able to give me this nicer looking QQ plot than I was able to get the other way. So I just wanted to point out what I was doing there. Figure 4 is a plot of all 10 pairwise differences across the 5 measurements to check for sphericity. So here you see I have a caption, plot of weight differences for all pairs of weeks to check for sphericity. And now let me show you another thing that I've added here, because really what we can do is look at the variances of each of those values, and I do that here. In fact, let me show you what I say. There appear to be disparities. To check if this is concerning, I calculated the variance and found that the ratio of the largest to smallest variance is over 6, so this is concerning. Some people like to be real conservative and say it shouldn't be more than twice as much. Most people and most research I've encountered will use 4 as the cutoff. You don't want the largest variance to be more than 4 times the smallest variance, but ours is over 6, so we have some concerns. But let me show you how I found that. So coming down here, after I went ahead and did what you saw me do in an earlier video in order to create that plot, that is, create all those differences, you'll see here that I use the tapply function in order to calculate the variances for those differences grouped by difference number. The difference number is here on the x-axis. So those 10 numbers here will give me 10 different variances. And then once I found those 10 variances, I took the ratio of the maximum of those variances to the minimum of those variances, and that's where I got that 6. So if I was to go ahead and run this here and look in my console window over here and then in my environment, you see I have var ratio. Well, if I look down here at var ratio, there it is. It's 6.25, 6 1/4. So that variance ratio, and here's all the variances right here. There should be 10 of them, and there are 10 of them. That ratio of the maximum to the minimum was 6.25. So that's where I came up with that language about this being concerning. And so I say that, let's see, here it is. I say that we have not met either the normality condition or the sphericity condition, so I should seek a robust method, but for this class exercise I will proceed and alert the reader to my concerns. I also wish I had a bigger sample size to address the normality of the sampling distributions of the means and to obtain more stable and believable estimates of variation. So there's where I'm warning the reader, telling the reader I'm going to plunge on, but warning that there are concerns here. Table 2 is the analysis of variance for the factors in the split plot design. There is a condition by time effect, p equals 0.025, so Rogaine does appear to increase hair weight. Remember, however, we've not met the conditions for valid inference. The true p statistic might be something larger, perhaps even larger than 0.05. Table 3 is a display of the hair weight gains across 3 different periods of time for both the control and treatment conditions. The table also includes 95% confidence intervals for the difference in gains. For all 3 of these time periods, there was a clear difference in hair weight gain between Rogaine and the control condition. So notice what I've done. I've mentioned in the past that whenever I do tetrads, I like to focus on each of the differences. So here are the differences from 1 week to the next for the control group. Here are the differences from 1 week to the next for the Rogaine group. And it's the difference of those differences that creates this column here of differences I have that is actually the value of the tetrad. But I think the value of a tetrad of 0.058 doesn't really convey the information as well as to say, okay, where did that 0.058 come from? It came from a control of 0.00325 here and a Rogaine gain of 0.061, and the difference of those is where that 0.0578 came from. And then I have a confidence interval for the difference, and I notice I only have 1 bound of the confidence interval. So let me pause and correct that, and I will be right back and we'll look at that confidence interval difference. Okay, so I've made that correction. What I determined is that it was only showing the lower bound of the confidence interval. So I've gone ahead and added the upper bound of the confidence interval and created this table. Now, this is a table a little bit different than what I've ever shown before, but I think it's a real clean, informative way to show these confidence intervals. So let me show you how I did that in my code. So what I did here is I calculated up here at the top. This you can see in previous videos where I actually calculated the means and the variance, standard deviation, the critical value, calculated MO, and then calculated all the confidence intervals and the contrast. So that's all in a previous video, what's up here. But what's new is this section right here. And so what I did is I created a data frame in which in the data frame, I'm going to have 1, 2, 3, 4, 5, 6 variables. The first variable I'm calling interval. And notice what I'm doing is I'm putting each of those week intervals here in quotation marks, week 0 to 32, 8 to 32, 0 to 16. And that's what allows me to get this down here in this, this first column when I print it out. And then I put in the control gain. Now, in order to have that control gain, I notice when it's printed out, it actually printed as control dot gain. I wish it had done it as control space gain, but I'm not going to worry about that right now. But because this was 2 words as one variable, I used that little tick mark to encompass those 2 words, and that will tell R that this is 1 variable, not 2. And I put in those pieces that I used up here when I calculated the different parts of the confidence interval. So I was looking at the control gain and the Rogaine gain, and then I put them all together in order to get the contrast. So here I'm showing them separately, I'm showing them all together. And then notice that when I created the confidence intervals, I saved each of those confidence intervals. So here, for instance, is the third one on line 196. And so with the lower bound, I'm just putting the first element of that third confidence interval. And with the upper bound, I'm putting in the second element to get this lower bound of CI and upper bound of CI. So this is the way it all turns out. The other thing I snuck in here was a digits equals 2 so that it retains 2 digits beyond the zeros for each of these values. And also I notice here like there's more than 2 digits beyond the 0, but it's in order to keep these all consistent, to keep them so they're all showing the same number of zeros, and it helps them all line up nicely. So that's how I was able to get this table 3 down here, which I find useful. Now on to the conclusions. The primary question of interest is whether Rogaine increases hair weight gain. The answer is that it does. For the sample of 8 women, 4 randomly assigned to each of the 2 conditions, the average hair weight gain across 16 weeks was about 0.05 milligrams per centimeter square higher than without the treatment. And this difference was sustained. You might ask, where are you getting that 0.05? Right here, under the difference column. Notice that they're all pretty close to about 0.05. And then I say this difference was sustained for the remainder of the 32 weeks. The effect of Rogaine can also be inferred to the wider population of women. From these data, we cannot make inferences about specific gains. In other words, if you look here at my confidence intervals are too wide to provide me much information. The confidence intervals are here, the last 2. So they're too wide to provide me much information. However, in the omnibus, I was able to reject, and therefore I'm saying that it can be inferred that there is an effect of Rogaine, but we don't know where those specific effects are. And then notice what I put here in italics. Caution, inferential statements may be incorrect due to not meeting the conditions for valid inference. When I'm writing all this up in non-technical terms for the public, I say in a 1990 study, researchers conducted an experiment to test the claim that Rogaine can lead to increased hair weight for women. An analysis of this data confirmed that indeed Rogaine does lead to increased hair weight. In fact, after 16 weeks, weight gains with Rogaine were about 6 times higher than without, and these gains were sustained for the remainder of the 32 weeks of the study. Researchers caution that although they are reasonably confident in Rogaine's efficacy for increasing hair weight, from these data, they were unable to infer to the general population of women just how large these gains would be. and how long the drug will need to be taken before realizing a gain. Nonetheless, the evidence suggests Rogaine is an effective treatment for women who suffer from pattern baldness. This research did not examine side effects, so women should consult with their physician prior to beginning treatment. But notice how I handled both the fact that we did find inferences, but we have to be really cautious about those. I said researchers caution they are reasonably confident, but they're unable to infer just how long the gains would be and how long the drug will need to be taken. So that's it. That's my final report here, and I'm looking over to see if it looks like it's formatted well. Always one of the last things I do to make sure the formatting and spacing looks good, and it looks pretty good to me. So I'm going to call it a day, and I will also call an end to this video series, and I look forward to seeing you in the next topic.